Hi there, folks. Today we're looking at multiplying polynomials. And multiplying polynomials, we're going to start off with binomials. Remember, binomials are two terms. Okay, so when we have two terms, that's two terms for binomials. We're essentially going to use our distributive property. And really, that's true for all polynomials. We'll essentially use our distributive property. It'll just look a little bit different and a little bit more complex because the more terms we have, the more stuff we have to distribute. Okay. So for binomials, we're going to use our distributive property. And when we do that with polynomials, but with binomials, things like that, we have to distribute each term of one polynomial to every term of the second polynomial, all right? So if I'm distributing a binomial, I essentially need to do my distributive property twice, once for each term, all right? If I had a trinomial, I would have to distribute 3 times, once for each term, okay? So I basically take each term individually and use my regular old distributive property, all right? Some teachers, if you've seen this before, will talk about FOIL, first, outside, inside, last. I think FOIL is a waste of your brain cells, and there's no need to remember FOIL if you remember your distributive property, okay? If you like FOIL, if you've used FOIL in the past, then go ahead and do FOIL. If you don't know what I'm talking about right now, then ignore that and don't worry about FOIL ever, okay? For example, if I look at this guy, again, I have two terms in this first polynomial, this term and this term. And what I want to do is I want to distribute each of those. So like I'm going to take the 3x and I'm going to distribute it to the 4x plus 5, okay? Then separately, I'm going to take the next term, the negative 2, and I'm going to distribute it to the 4x plus 5. Okay, that's it. I just split it up and say, hey, let's do my distributive property. And just have to be careful with your signs. Yeah, that's a negative 2 that I'm going to be distributing. So now I distribute. Ready? Here I distribute the 3x. And this becomes rules of exponents as I go. Watch this. 3x times 4x. 3 times 4 is a 12. But remember, this is an x to the first and x to the first. When I multiply, I add the exponents, so that's an x squared. And now when I do 3x times the 5, that gives me a plus 15x. Now I have to distribute the next term. I distribute the negative 2. So here I go. I'm going to distribute the negative 2. Negative 2 times 4x is a negative 8x. Negative 2 times 5 is a negative 10. All right, and now I just have to look for like terms because remember, I'm still allowed to add and subtract like terms. Look at these two in the middle. These are like terms, so I can combine those. That becomes a 7x. Remember, when I add like terms, I add or subtract the coefficients. The variable part stays the same. If I look at the next one, same kind of thing. I'm going to distribute each term individually. So I'm going to split it up. I'm going to say, hey, let's take this first term, the x, and let's distribute it to the 2x minus 8. And now let's take the next term, the minus 6, and let's distribute it to the 2x minus 8. It's just our distributive property twice. And if there were 3 terms in that first polynomial, I would do it 3 times. So now here I go. Let's do our distributive property. Remember, these each have an exponent of 1, so when I multiply, that's a 2x to the second, and then a minus 8x. Here, when I distribute this guy, that is a negative 12x and a plus 48. Just doing my distributive property. Now look for like terms. Look at the ones in the middle. It's an x to the first and an x to the first. Those are like terms, so I can combine these. So now I have a 2x squared. A negative 8x minus 12x, that's a negative 20x plus 48. Okay? And so now here's the thing. There's a little bit of a shortcut we can do it after we get used to this. All right? If you're looking at that thinking, man, that looks easy and I can keep doing that forever, go for it. All right? You split up that first polynomial and you do your distributive property a couple times. Combine like terms and you're done. Okay? But instead of actually splitting them up, okay, what most students do is they start to split these up kind of in their head. They say, you know what? If I just ignore the 1 for a second and do my distributive property, I don't need to write that 6x times the negative 3x plus 4. I can just pretend the 1's not there. Just ignore them for a second and distribute. That gives me a negative 18 x squared. Again, when we multiply, we add the exponents, an x to the first and x to the first. And now the 6 times the 4 gives me a plus 24x. And now they say, hey, let's ignore the 6 and distribute the 1. And when we ignore the 6 and distribute the 1, sorry, I should have given myself just a little bit more space here. Let me scoot this guy out of the way. When I ignore that 6 and I distribute the 1, that gives me a minus 3x and a plus 4. Now I can combine like terms. The 2 in the middle, these are like terms. They're both x to the first values. So that's a negative 18x squared plus 21x plus 4. And notice it doesn't really save us all that much. It saves us one little step in there to eliminate that kind of splitting that first thing up, okay? But most students do it this way, all right? And some of them refer to this as kind of like the claw. You see those little arcs on each end. But this is where FOIL comes into play. If you look at what I did here, it's the first term times the first term, the outside term times the outside term, the inside terms being multiplied, and then the last terms, okay? Again, I think that's a waste of your time to memorize that because it's so much easier just to remember to do the thing you already know how to do, which is the distributive property, okay? And if you don't like the shortcut I just did there, that's okay. You don't have to do the shortcut. Split it up, all right? So you'll come off to the side here and you'll do 6x times the negative 3x plus 4, and then you'll do the plus 1 times the negative 3x plus 4. You'll take the time to write that. Would that take me 10 seconds? And now your next step will be the same as mine as you go to distribute, okay? It's just the distributive property twice, all right? This one, I'm going to do the shortcut again. So let's imagine that I'm ignoring that negative 4, so I'm just distributing the 2x to each of these. And once again, these are exponents of 1. So let's see, that's a 4x squared plus 8x. And now let's ignore the 2x and distribute just the negative 4. And yes, that's a minus 4, so it's a negative 4. So that gives me a minus 8x and a minus 16. And now I combine like terms. The 2 in the middle, these are like terms. When I add these together, it gives me a 0, which means I don't have an x term anymore. I just have the 4x squared and the minus 16. All right? Again, you do not have to do that shortcut. You can take this off to the side and go, you know what? I'm going to do 2x times the 2x plus 4. And then I'm going to do the negative 4 times the 2x plus 4. There it is. There's the extra 10 seconds. And now your next step will be the same as mine. Okay? It's just the distributive property twice. Went a little bit farther. If I look at something like this guy, it says the area of a rectangle is length times width, so find the area of the rectangle. Notice the length this time is x plus 4. The width is x plus 1. So I'm going to do, okay, the area equals the length times the width. And here it is. I'm going to show the shortcut again, all right? So the shortcut is, let's just ignore the 4 for a second, so let's just distribute the x. And once again, these have exponents of 1, so as I distribute the x, let's multiply. That's an x squared plus 1x. And now I say, okay, let's ignore the x and just distribute the 4. So pretend that x isn't there, just distribute this 4. That's going to be a plus 4x and a plus 4. All right? And once again, you don't have to do that. You can come over here. Ready? I'm going to multiply by the x, so I'm going to distribute the x. And then the next term is the 4, so I'll distribute the 4. There's that extra 10 seconds. And now back over here after you multiply, okay? It's okay to not do this shortcut that I'm doing. It's not going to save you a whole lot of work anyway, all right? And now combine like terms. These guys are like terms. So when I add them up, that's a plus 5x. Okay? And that's it. This represents my area. And yeah, I don't know what x is, but the second I know x, I can plug it into this guy and I have a formula already set up for the area. Okay? So now let's expand this a little bit. Ready? So that was all binomials. Everything we just multiplied was a binomial times a binomial. Now I have a binomial times a trinomial. Remember, three terms is a trinomial. All right? But really, it's the same thing. And if I kind of do the thing that I've been doing, all right, let's go back to old school here. I'm just going to take each of these terms and distribute each of them separately. So watch this. I'm going to take the x, and I'm going to distribute it to the negative 2x squared plus 6x minus 3. And now I'm going to take the next term, which was a plus 3, and I'm going to distribute it to the negative 2x squared plus 6x minus 3. And now it's just my distributive property twice. Ready? Let's distribute that x to each of these. And keep in mind that has an exponent of 1. So when you multiply, you add the exponents. So this is a negative 2x to the third plus 6x squared, because here's another exponent of 1. Remember, you add the exponents, minus 3x. And now distribute this 3 over here. Ready? Let's distribute the 3. This is the easy one, negative 6x squared plus 18x minus 9. And now combine like terms. Remember, I'm looking around for like terms. I always go in order. I look at the biggest exponent and say, okay, this guy, he doesn't have any like terms, so I just write him down. And then I look at these guys. Oh, these are like terms. So when I add them up, oh, they actually give me a 0, so those are gone. These guys are like terms, and they give me a 15x. And then the minus 9 doesn't have a like term, so he just tags along for the ride. Okay? It's just my distributive property, but I'm distributing to something bigger now. And can you see that we can apply that same shortcut? I could ignore the 3 for a second and just distribute the x to each of these. And then I could ignore the x for a second and just distribute the 3 to each of these. Okay? And that's it. It gives me the same thing, and really, it doesn't save me a lot of work. It just brings me right to this step without having to write that first thing. Okay? If I look at the next one, again, let me try the shortcut this time. Ready? Ignore that negative 5. So I'm going to ignore that negative 5. I'm just going to distribute the 2x to each of these. Okay, so ignore that negative 5. Remember, that's next to the first here. This one's also next to the first. So now I multiply. That's going to give me a 2x cubed minus 14x squared. Remember, I add the exponents. When I multiply, I add the exponents, plus 8x. Now let's ignore that 2x. Pretend that 2x isn't even there. Let's distribute that negative 5. And yeah, it's a negative 5 that I'm distributing. So that's a negative 5x squared plus 35x and then minus 20. And now it's combined like terms. This guy doesn't have a like term, so he stays the way he is. The x squareds, these are like terms, so that's a negative 19x squared. These guys are like terms, so that's a plus 43x. And then this guy doesn't have a like term, that's a minus 20. Okay? And again, if you're looking at that shortcut saying, I don't like that, Mr. Jansen, you don't have to like it, all right? You don't have to use it. Take the 2x and you're going to distribute it to this guy. And then take the minus 5 and distribute it to this guy. It's just your distributive property twice. And now you're back to the same step that I was at. It takes 10 extra seconds to do it and make sure you get the right answer, okay? If I look at this one, okay, this is where students don't like the shortcut. This is where the shortcut kind of falls apart on us because students start to do this. They go, all right, let me ignore this guy and try to distribute this thing. And then I got to ignore the other ones and distribute this guy. And then I got to ignore, oh no, now that's no good. You know, if Ghostbusters taught us anything is that you don't cross the streams here, all right? So we can't have, all right, this is a mess now. I can't see what's going on, all right? If you're going to use your shortcut on this one, the recommendation is you distribute it backwards. So you say, hey, let's ignore the minus 2 and distribute the 4x. And now let's ignore the 4x and distribute the negative 2, okay? And if you're looking at that going, oh, I don't like distributing backwards either, ready? Let's do it the old school way. Let's do it without the shortcut and just say, hey, let's take the first term, which is the 3x squared, and distribute it to the 4x minus 2. And now I take the next term, the negative 2x, and distribute to the 4x minus 2. And now take the next term, the plus 5, and distribute it to the 4x minus 2. See, I have 3 terms, so I just do the distributive property 3 times. I do the distributive property with each of those terms. And that's it. Now I go ahead and distribute. Ready? I'm going to distribute this guy. Once again, that's an x to the first. When I multiply, I add the exponents. So 12x to the third, and then minus 6x squared. Once again, that's a 1, that's a 1. When I multiply, I add the exponents. All right, so that's going to be a negative 8x to the second and a plus 4x. And then the last one here, I distribute that 5. Easy peasy. That's a plus 20x and a minus 10. I have 3 terms. I do the distributive property 3 times. And now I combine like terms. This guy doesn't have a like term, so I just rewrite them. That's a 12x cubed. Here, these guys are like terms, so when I subtract or add those negatives together, that's a negative 14x squared. These guys are like terms, so that's a plus 24x. Sorry, I got some little dots here I got to get rid of. And then this last one doesn't have a like term, so it stays as a negative 10. All right. And if you do your shortcut here, if you did the shortcut by distributing this guy backwards, that's okay. You'll get the same terms kind of in a different order, but then as you combine things, you'll get the same thing that I got, okay? But again, when we're multiplying polynomials, it's just the distributive property multiple times, okay? If I have 2 terms, I distribute each of them, so I do the distributive property twice. If I have 3 terms, I distribute each of those terms, so I do the distributive property 3 times, okay? And as I multiply, I have to remember rules of exponents. When I multiply, I add the exponents.